Today we're moving away from now operations with radicals and operations with fractions. Now we're just going to be looking at the different types of numbers that we know and that we've been interacting with. So first, all of the numbers that we are dealing with so far are real. So all the numbers we know are called real numbers. Imaginary numbers will come later, but right now everything we know is real. And so in this big set of real numbers, there are smaller subsets and different ways for us to organize the numbers that we know. So we're going to start down here in the smallest, most exclusive subset and then work our way out. So natural numbers is our smallest subset of the real numbers, and this includes the counting numbers. So when you count, you usually start at 1, go 1, 2, 3, 4, 5. Those are natural numbers. So the counting numbers. So 1, 2, 3, 4, etc. Notice that when we're counting, the natural numbers start with 1, not 0. So 0 is not included in the natural numbers. It starts with 1, and you count up. Okay, and then moving up. So whole numbers is our next subset. This is very similar to the natural numbers, but now we can include 0. So it's all the natural numbers plus 0. So the counting numbers. So counting numbers and 0. So we can have now 0, 1, 2, 3, 4, etc. Okay, so the only difference between these two is that whole numbers includes 0, natural numbers does not. And again, if you notice the way that this diagram is set up, the natural numbers box is inside the whole numbers box because any number that's a natural number is also a whole number. So whole numbers include all of those. 0 is just the one that's exclusive to whole numbers. So now we've been dealing with our positive numbers and 0. So now integers is where we add in the negatives of those. So we now have positive and negative counting numbers and 0. So we have -4, -3, -2, -1, 0, 1, 2, 3, 4, etc. So any positive or negative counting numbers. So we're not dealing with decimals yet. We're not dealing with fractions. Just the nice integers, positive and negative, and 0. And then again, the diagram, integers includes whole numbers and natural numbers. So any number that's a natural number is whole, and it's an integer as well. So you work your way out. And our next one is the rational number. So this is basically every other number that we know except for irrational. So I'm actually going to do irrational first because it's a smaller group and easier to define, and then rational I can do in a minute. So irrational is kind of off to the side. It's its own thing. It's its own part of real numbers. It's not associated with any of these integers, whole, or natural numbers. It's just its own thing off to the side. Irrational numbers are like when we have square roots that we can't evaluate, so like square root of 3 or square root of 5. So square roots we can't evaluate. So like square root of 3, square root of 26, negative square root of 7, any square root that if you try to do it in your calculator, it wouldn't give you a nice number. It'd give you that really long decimal. Irrational numbers There's also a very popular irrational number called pi. That's irrational because pi goes on forever and ever and ever, and there's no pattern to it. Okay, so anything involving a pi, we could do, even if we had like pi divided by 2, that would still be irrational. 3 pi, that would be irrational. Anything that has the pi involved is irrational, and whenever we have square roots of numbers that we can't evaluate nicely are irrational. So since these are irrational, then the square roots we don't know, and anything with pi, rational numbers is just everything else. So to put it simply, rational numbers is anything that's not irrational. So a number cannot be rational and irrational at the same time. It can either be one or the other. Rational numbers so includes everything from before. It includes our integers. It includes the whole numbers. It includes the natural numbers, all of that. So our positive and negative counting numbers and 0. And then with rational numbers is where we add in fractions. So it has all 3 of these things and fractions. Terminating decimals. And repeating decimals. Okay, so again, it has all of the natural, whole, and integer. So we can have like 1 or negative 2, negative 1, 0, 1. All of those things are still included. But then we can also add some fractions and decimals. So like 1.5 is a rational number. 1.6 repeating is rational. If we had like 8/9. Any sort of decimal that either terminates, like 0.25, or any repeating decimals when you have that bar across, any fractions, those are going to be rational numbers. So basically, if it's not a square root we can evaluate and it doesn't involve pi, that means it's rational. Okay. So we're going to move on now because basically today we're just going to be practicing identifying these different types of subsets and classifying numbers, putting them into a subset they belong. So just some reminders down here. All numbers that we know at this point are real. So whenever you are asked, hey, what type of number is this? Real should always be one of your answers because everything is real. Just like when we were doing stuff with fractions and stuff with radicals, simplifying was a big deal. Before you can start classifying any numbers, you have to make sure that they are simplified all the way, and then classify the simplified form. And then numbers are usually going to be in more than one subset. So for example, if we have a number that's whole, so like 0, 0 is a whole number, it's also an integer, it's also rational, and it's real. So whatever the first subset is that it falls in, it's also everything above it. Okay, so keeping those in mind, we're going to do this example 1 together. So we have a set of numbers, and we just want to list the numbers in the appropriate subsets here. So first, before I even worry about classifying, I'm going to look at all of my numbers and make sure that everything is simplified. So -7, there's nothing more we can do there. -3/4, can I simplify that anymore? No, but remember, if it wasn't obvious, you can use your calculator to check, right? If fractions are reduced, you could do 3 divided by 4 and then the math, enter. 0 is already reduced, 0.6 repeating is reduced. Square root 5. Can we evaluate square root 5? If you do square root 5 in your calculator, do you get a nice number? No. Can any perfect squares go into 5? Okay. Pi is already, can't do much with that. 7.3 we can't do much with. What about square root of 81? What's the square root of 81? 9. So that means when we are classifying this, we are going to treat square root of 81 as the number 9. Okay, so everything is simplified, so now we can start classifying. So if we look at our first one, so natural numbers, these are the counting numbers. So numbers starting with 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. going on. So looking at our set of numbers that we have to choose, do you see any counting numbers in this list? 9, yeah. Anything else? No, that's the only one. So natural numbers would be, you can write square root of 81, which is equal to 9, just so we know that the square root of 81 was the actual number that was written in the set, but it's equal to 9. And now, when a number is natural, this box is in all of the other ones. So that means 9 is also whole, it's also an integer, it's also rational, and it's also real. You just go all the way up. So we can put that 9 in all these different subsets right now. So natural number is also whole. It's also an integer. It's also rational. And it's also real. The only one it's not is irrational, because a number cannot be rational and irrational at the same time. Okay. It'd be good to write the square root of 81, because that's what was actually put in the list, just to keep it consistent. Okay. Everybody good why 9 is in all of those? So natural numbers, if it's a natural number, it's going to be in almost everything, except for irrational. All right. So natural is done. Let's move on to whole now. So whole numbers now are the natural numbers. I'm actually going to cross out 9 since we're done. We did it. We put it where it needs to go. So whole numbers include the counting numbers, so the 0 or the 1, 2, 3, 4, 5, 6, 7, 8, 9. We already have 9. But what's different about whole numbers and natural numbers? What makes it different? The 0, yeah. Whole numbers includes 0. So did we have a 0 in our list? Yes, it's right here. So that means we can have 0 here as a whole number. And then if a number is whole, again, you just work your way up. It's also an integer, it's also rational, and it's also real. So we can put it with integers, we can put it with rational, and we can put it with real. Okay, so now I'm done with 0. And I'm done with whole numbers. Okay, let's take a look at our integers now. So integers are now where we have the positive and negative counting numbers and 0. So looking at our list, do we have any positive or negative counting numbers here that we haven't dealt with already? Yeah, -7. And I think that's the only other one. So -7 is an integer. And then looking at our diagram here, if a number is an integer, you go up. So it's an integer, it's also rational, it's also real. So integer, rational, and real. Okay, so we're done with -7. We're done with integers. Okay. So this is where you can do rational next, but since that includes a lot more, I like to do irrational first, because remember, a number can't be irrational and rational at the same time, and there's fewer things to worry about with irrationals. So if we look at the numbers that we have left that we haven't put anywhere, which of these are irrational? So remember, those are square roots that we can't evaluate, and anything with pi. Yep, I see pi right away. Anything else that's irrational? Yeah, the square root of 5. So both of these are irrational. And if a number is irrational, it's also real. Everything is real. So I'm done with those. And so since those are the only two irrational, that means everything else is rational. So we have the fraction, the -3/4, our repeating decimal, 0.6 repeating, and our terminating decimal, 7.3. All three of those are rational. So -3/4, 0.6 repeating, and 7.3. And then if a number is rational, it's also real. So -3/4, 0.6 repeating, and 7.3. And we've dealt with all of our numbers in our set there. So again, just some checkpoints or ways to just double check your work. You can look at your rational and your irrational. Make sure no number is in both, right? Because a number can't be rational and irrational. So do we have any numbers that are in our rational list and our irrational list? No. So that means we're good there. And then with our real numbers, all numbers should be here. So whenever you are listing real numbers, that's just every single number that we're giving you in this set, because all we're dealing with right now is real numbers. Okay, so on the back, there's one more example where instead of giving you just a list of numbers and having you put them in the subsets, I give you just one number and you need to list all of the subsets that it is included in. So remember, when you use this, let's say like we have 0 again, just start from inside. Is 0 a natural number? Is 0 a natural number? No. Is 0 a whole number? Yes. So wherever your first yes is, it's that subset and then all of the ones above it. So just make sure you're going up. Okay? So I want you guys to go ahead and try example 2. So you're going to be listing all the subsets that each number belongs to. Remember, they will have at least 2. Real and another one. Most will have more. So I'll give you a few minutes to try. So our first one is -9. So again, the best way just to make sure you don't forget any subsets is just to always start in the smallest one with the natural numbers and just kind of work your way out. So is -9 a natural number? No. Is -9 a whole number? No. Is -9 an integer? Yes. So since that's your first yes, it's integer and then everything above it. Rational, real. So you should have for -9 is integer, rational, and real. Okay. What about letter B? What was the first subset that pi over 2 falls in? If you work your way from the inside out. Is it natural? Is it whole? No. Is it an integer? It's irrational. Thank you. Irrational and real, because everything is real. Okay, letter D, 0.3 repeating. What was the first subset that letter D falls in? Rational. And real. Work your way out. Square root of 9. What is the first subset? Yeah, go ahead, Angelina. Natural, yeah. Why is that not irrational? Because there's a square root. Yeah, it's a square root of a perfect square, which is equal to 3. So just because you see a square root does not automatically mean it's irrational. You got to make sure you simplify. So yes, since square root of 9 is equal to 3, we treat it like a 3, and the first set that 3 falls in is natural, and then it's everything above. So natural, whole, integer, rational, and real. And then our last one, f has 0. What's the first subset 0 falls into? Whole. Whole, integer, rational, yeah. And real. Okay. Do you guys have any questions?